programmable gate array. Field programmable gate array is a flexible architectural programmable logic device. It is a very large scale integrated circuit, VLSI circuit constructed on a single piece of silicon. It consists of identical individually programmable rectangular models. These models are separated in both horizontal and in vertical directions by horizontal and vertical metallic conductors called as channels. FPGA is a VLSI circuit that can be programmed at the user's location. A typical FPGA consists of an array of million of logic blocks surrounded by programmable input and output blocks connected together by a programmable interconnection. Any type of digital hardware circuit can be implemented in a FPGA architecture. The configurable logic block can be used to design basic combination logic circuit to complex processor architecture. FPGA architecture. So today we are seeing Xilinx FPGA, which is launched in the year of 1985, and it is the world's first commercial FPGA. And XC3000 and XC4000 families are later introduced. Before that, XC2000 was introduced first. Each evolution of devices brought the improvements in density, performance, power consumption, logic, voltage levels, pin counts, and functionality. So, for an example, the Spartan family of devices initially offered a maximum of 40K system gates, but today's Spartan 6 offers 150 100,000 logic cells plus 4.8 MB block RAM. So, basically, the architecture of FPGA will be explained by using the Xilinx Spartan. So, here we have it consists of configurable logic blocks, configurable input output blocks, programmable interconnect, clock circuitry for driving the clock signal to each logic block, additional logic resources such as ALUs, memory, and decoders. So here we are using two basic type of programmable elements. One is SRAM, other one is antifuse. So configurable logic block. So configurable logic block contains programmable lookup table. Okay, programmable lookup table, a multiplexer, a register, and path for the control signals. Okay, two of the function generator of the lookup table can generate any function of four inputs, and the third function generator can generate any boolean function of three inputs. So let's consider this as F, B, and H. Okay, so the function block can get its inputs from the F and G. Okay, the lookup tables are from the any external inputs. The function generators are programmed to generate three different functions of three independent sets of variable, and the arbitrary function has five variables, and the arbitrary function of four variables together with some functions of six variables. Some functions might introduce around like nine variables. So each configurable logic block consists of two flip-flops or two slices that can be configured as edge triggered flip-flop with edge triggered flip-flop with a common clock. Those storage element can get their inputs from the function generator. The function generator can also drive the two outputs directly and independently of the outputs of storage element. Output pins has a programmable input output buffers that are compatible with TTL and CMOS signal levels. It can be used as an input output or bidirectional. An input output block that is configured as an input can have direct latched or registered input. So here we see the output buffer of an input output block as a skew and slew control. The slew rate of the output buffer can be controlled to minimize transients on the power bus when non-critical signals are switched. The register available to the input output path. So these are the registers that are available at the input output path of an IOB or driven by separate invertible clocks. So here we see next one is programmable interconnect. So it is nothing but a grid of switches. It's a grid of switches. Switch matrices overlays the architecture of CLBs to provide general purpose interconnect for branching and routing throughout the device. The programmable interconnect resources of the device connects CLBs as well as IOB. CLB is nothing but configurable uh, CLB is nothing but configurable logic blocks, and IOB is input output blocks. Okay, so either directly or through the switch boxes. So interconnect has three types of general purpose interconnects. One is single line, and the other one is double line interconnects, and the other one, third one is long lines. The grid of horizontal and vertical single line interconnects connects an array of switches that provide a reduced number of connections between the signal paths within each box. Direct interconnect lines provides the routing between adjacent vertical and horizontal CLBs in the same row or column. So these are relatively high speed local connection through metal, but are not as fast as hardwired metal connections. Special long lines. So special long lines called as global clock lines are specially designed for low impedance and thus for the faster propagation times. These are connected to the clock buffers and to each clock element in the each CLB. So here we have types of FPGA. So first one is SRAM, second one is antifuse, and third one is flash EEPROM. So SRAM programming involves a small static RAM bit for each programming element. Writing the bit with a 0 turns off a switch, while writing with an 1 turns on the switch. Another metal involves an antifuse that consists of an microscopic structure structure that, unlike a regular fuse, normally makes no connection. A large amount of current during programming of the device causes the two sets of the antifuse to connect. A third and relatively new method uses flash EEPROM bits for each programming element. So, advantages of FPGA. These are cost efficient. FPGA or reprogrammable. No physical manufacturing steps are involved in it. FPGA allow you to finish the development of your product in a very short time, and it has better performance than the general CPU, and they are capable of handling parallel processing. So it also has lower non-recurring engineering costs and can be used for more than one application. So disadvantages is high power consumption, and they are used only when the production volume is low. And programming in FPGA is not as simple as C programming. So applications of FPGA, it is used for ASIC prototyping, application specific integrator circuit programming. Okay, so for image processing using in SDR, and for diagnosis and therapy in medical field, and in wireless systems such as WiMAX and WCDMA, etc. In consumer electronics like flat panel display, residential set-top box, etc. So, in consumer electronics, cost-effective solutions enabling next generation and full feature consumer application such as handsets and flat panel display and home networking. So, FPGA covers all those applications. And in terms of medical field, It is used for diagnostic monitoring and therapy applications. And Silex offers solutions that meet the evolving needs of security applications, from access control to surveillance and safety systems. So, thank you.